Hey guys, it's Dr. Jansen, and today we're going to talk about combining like terms. So let's get started. All right, so let's look at this expression that we have in front of us. So we see some different terms here. We see some that have variables, which are just, again, variables, just another word for a letter. We see some that don't, that are just numbers, and we see some that have a letter, a variable, and then a number in front of those. So we see all different kinds of terms here. So let's talk about that. And we're going to actually identify those terms and put them in different categories. So first, let's talk about the ones that have variables. And let's actually point those out. We have this one here, 14x. We have this one here. We want to always take the signs with them, so because that tells us whether it's positive or negative. So I wanted to put it in the box, but when I write it down, it's just, I know that means it's just a positive x, so just a 1x. Let's see if I see another one. Oh, right here. Negative 7x. So if it's negative, that sign comes with it when I write it down. If it's positive, we don't write plus in front of all of our positive numbers. So these are actually called variable terms. Variable terms. It's a really fancy way, variable term, of referring to it, but these are just the ones that have variables. That's what we call them. And then there are the ones that have numbers. Let's write those down. They would be the other ones here. So we have -3. We have +5, which again, we don't write down that positive in front of all of our numbers, and 12. And the fancy word for this is a constant term. Ooh. But these are really, they're just numbers. That's all they are. So those are the two categories that we put things in when we combine like terms. That's it. It's either a variable or it's a number. Variable term, constant term, it's either a variable or it's a number. That's it. So, and the thing with combining like terms is you can only combine variables with variables. That's the rule. It doesn't get more complicated than that. You don't even need to write out some big fancy rule. Here is your rule. You can only combine variables with variables, with variable terms. So you can only combine a term that has an x with another term that has an x. That's it. And it has to be the same variable. So if this is an x, it's got to be another x. If it's a y, it's got to be a y. If it's an n, it's got to be an n. Whatever. Okay? And the same thing. You guessed it. You can only combine a number with another number. That's it. That's the rule. That's the whole lesson. You can only combine, that's why they're called like terms. Make sense now? You can only combine them if they are alike, okay? And then if you run into terms like this, like let's say we were going to combine all of these variable terms together. There's these things that live in front of variables called coefficients. It's another fancy word. We have some very fancy words in math, my friends. And coefficients are just the numbers that are in front of the variables. So here, the coefficient of this first one is 14. What's the coefficient in front of this one if there's nothing? It's not a 0. I was just like pointing that out. It's always 1. If there's nothing in front of the variable, it's always a +1. And then what is the one, I'm just getting rid of that line up there. What's the one in front of this one here? It is -7. So it's literally just saying what is the number in front of your variable. That's it. So what we do is when they all have the same variable ending is what we're going to call it. They have to have the same variable ending in order for us to be able to combine them. If they have the same variable ending, then we just add their coefficients together. Okay, let's start with what if we wanted to go ahead and just use our example problem as the first problem we were going to go ahead and try to solve. So let's try to solve this problem that we have right here, this 4x minus 3 plus x plus 5 minus 7x plus 12. So first we're going to look and see if we have any variable terms that have the same variable ending. So here we have 14x, x, and negative 7x, as we already marked before, that have the same variable ending. So we can go ahead and combine those like terms because they all end in just x. And the way that we combine those, like we said before, is we just add their coefficients together. And that's going to be 14. And here, again, that coefficient is always just 1 in front of the x. If there's nothing in front of our variable right there, it's always just a positive 1. So 14 plus 1 minus 7. And I'm just going to punch this in my calculator because I want it to be accurate. 14 plus 1 minus 7. And I get 8. So that gives me 8x. I'm just going to write it right here. And don't have any other variable terms to combine, so that part's done. And now I'm going to do these number terms, or again, fancy word, constant terms. And same thing, I'm going to put this in my calculator. I'm going to get negative 3 plus 5 plus 12. And I get 14. And so this all simplifies to be 8x plus 14. So there you go. Let's do another problem. We have 9x minus 4 plus x minus 2. So again, first we're looking for any variable terms with the same variable ending. Here I have 9x and positive x, so those are like terms because they both have the same variable ending. Again, there's really a 1x in front of that x, so I'm just going to, in my calculator, I don't need a calculator for this one, 9 plus 1, I can do that. Hopefully you guys out there can too. And we get 10x when we combine those. Again, for the ending, if some of you guys are getting hung up on that, it just stays whatever ending they share. So here they share an ending of just x, so it just stays x. It's not 2 x's or anything. It stays exactly whatever ending they share. You just write it once, and because you combined them together, and so it's just whatever ending they share. You just write that one time. And then now we're going to look at these number terms. And negative 4 minus 2 is negative 6. If you're not great with integers, you can just punch that in your calculator to make sure you get the right answer. And that reduces to be 10x minus 6. We're going to do one more here. And that is negative 24. I'm going to write that a little neater. Negative 24x plus 12y plus 10 plus 6y plus 8x. Again, same thing. We're looking for any variable terms that have the same variable ending first. Here I have negative 24x. Do I have any other x terms? I do right here at the end. I have a positive 8x. So negative 24 plus 8 gives me negative 16x. Again, not great with integers, just punch it in your calculator to make sure you get the right answer. And next I have another variable term. I have positive 12y, But there's a difference between this variable term and this variable term, and that was that one ended in x and one ended in y. So you have to be careful about that. They have to have the exact same variable ending. I cannot combine an x and a y. Those are not like terms. They're both variable terms, but they don't have the exact same variable ending. They have to have the exact same variable ending. They have to match exactly in order to be able to combine them. So I can combine x's with x's, but not x's with y's. So I can combine this 12y with this positive 6y because they both end in y's. So in order to do that, I'm going to take positive 12 and positive 6, and I can combine those as well, and that gives me positive 18y. And then I have this positive 10 hanging out here, but I don't have any other number terms. And so we just carry down that positive 10. There's nothing to combine it with. And simplifying that expression leaves us with negative 16x plus 18y plus 10. And you have put both of those expressions in simplest form. Great job.